Okay. Sorry, I was having a little camera problem, but I think it's working now. So this is a special little project. Your brother ran across this problem in a AMC10 last week, I think.
Yep.
And I talked about it with you because you and I had been talking about different base numbers.
Yep.
But this is a pretty advanced problem. And I just wanted to hear you talk about it again. And because James Tanton did a video about this. It was a really cool video, and we're going to watch it after you give this talk. Okay?
Yeah.
So do you remember this problem?
A little bit.
A little bit, okay. So it says a base 10 three-digit number is selected at random. What is the probability that this number is also a three-digit number in base 9 and in base 11? Okay, do you understand the problem?
Yeah.
All right, what do you have to do to get the answer to this problem, to get that probability?
Well, you have to know what the problem asks, and you have to know what's on the bottom.
What's that? Okay, so what is going to be on the bottom?
Well, the total number of three-digit integers in base 10.
Okay, good. So that's going to be on the bottom.
And then, well,
what's going to be on the top of your fraction?
on the top is what the problem is asking.
Which is what?
The number of numbers that satisfy this equation.
Well, it's not an equation. It's a condition.
Yeah,
What is the condition?
That this three-digit number in base 10 is a three-digit number in base 9 and base 11.
Okay, so good. So good. So we're going to look for a fraction. The top's going to be all the numbers that satisfy all those conditions. And the bottom's going to be the number of three-digit numbers in, what, base 10?
Yeah.
Okay,
And
awesome.
then, well, the three-digit base 10 integers are 1, they go from 100 to 999, so the bottom number will be 900.
Okay, that's cool.
And then the base 9, the base 9 three-digit integers, well, 100 in base, in base 9 converted to base 10 is 81.
All right.
And then they go to 728 because 729 in base 9 would be 1000.
Oh, interesting. Very interesting idea. 1000 base 9 is 729. So you can figure out the last three-digit base 9 integer by just doing what?
By just subtracting 1.
Wow, cool. Good idea. All right.
And then the base 11 three-digit integers go from 121, and then subtract 1 away from 1331, and then A, which is in base 10 is 330.
Okay. Cool. Good list.
And then, well, the first number that satisfies this is 121 here, because this is the start number and the highest base that we have, so it's going to work for all the other bases.
Okay. Interesting.
And then, so it goes from 121 to 7, and then we have to pick the highest number from our lowest base, so 728, subtract 120, so 1 is 608, and then that means 608 is on top.
Pretty cool.
608 over 900.
608 over 900. Huh.
So a little bit more than a half.
Oh, actually quite a bit more than a half. What would half of 900 be?
It would be 450.
Yeah. This is actually pretty near a fraction. Do you see what fraction it's kind of near?
well, 2/3.
It's kind of near 2/3, yeah.
Yeah.
Good job, man. That was a really nice talk about this problem. This is a very challenging problem. Good job.